Hello everybody. Today I will be showing you all how my partner and I modified our solar system simulation in order to add extraneous celestial bodies such as asteroids, comets, and meteorites using user input like mouse clicks. To perform these tasks, we made significant changes to our nBody class, so much that we've created a new class called nBody Extreme 2. Now the main differences are as follows. We needed to use a mutable list structure in our implementation. So rather than using simple Java arrays, we used array lists. That way we can easily add to the end of a list of celestial bodies when we need to. And also, that way we can consider planets, suns, asteroids, and meteorites to all be celestial bodies. In addition, we've modified our display such that the simulation interacts with users. In this way, users can use their mouse to add asteroids and meteorites to the simulation. And so I will demonstrate our work in these three examples. Oh, and asteroid class and inheritance body extreme. Simple as that. So, without further ado, we will get started. I'm going to run this code. Now, it looks a little weird right now, but all it's saying is, okay, I want to run the nBody Extreme 2 class with a length of this many milliseconds, with a difference in time of this many milliseconds, and I want to pull data from this file, which is going to show the regular solar system, the one that we are familiar with. So I'm going to run that, and we are going to get a window. Hopefully. Yes, here we have it. Here we have this functioning solar system, one that if you have already been doing Project Zero, one that you've seen before. Now the difference is I can add asteroids around to interact with the solar system. Right now they're going a little slow, but I can change that pretty easily. So what you might notice is that they're naturally gravitating towards the largest celestial body in the universe or in this solar system. And so with the biggest mass, and that's just going to be the sun. So as you can see, most of the planets and the asteroids are going to orbit the sun. Now you could see these asteroids shooting outward because, well, the asteroids are going to do one of two things. These bodies will either begin to orbit the largest body in the system, or these asteroids will move towards the body very fast. Will orbit the body once and accelerate out of orbit in another direction. So let's see if we can get a system to orbit, or asteroids to orbit the actual sun. So as you can see, it's kind of waving around, it's navigating through the sun because it is subject to the sun's strong gravitational forces. Even some of these you can notice that they might not all go all the way out, that they'll go out and they may come back. Well, that one didn't, but this one does. Pretty interesting stuff. I think this one will again, because it's not going in a fast enough direction, and it's being pulled by the gravitational forces. So that's pretty cool. And I've added some system.out.prints. This is for when I was testing it, but I think it's really helpful for the users to see as well. So this shows the position that I put the asteroids in this line. And in the second line, it will show you, and this one highlighted here, it'll show you the x velocity, the y velocity, and the mass. I've set the asteroids to be a constant mass of 1 e to the 15, but that's okay. And I will send an indication to me or whoever's running this program that a body has been added. And I suppose we can do one last one for fun. Let's see if I have a good one. The twin binaries was an interesting simulation because there are no suns in this system, that it is just planets. So what do you think would happen? Well, what do you think? if these planets have a similar mass, well, it's going to go towards the one with the largest mass, or the one that has the closest distance, according to the gravitational forces formula. And so as you can see, you might even see them navigate towards each other, navigate through each other, orbit, come back, orbit again. If it's approaching the force, if it's approaching the orbit fast enough, it will maybe possibly shoot out just like a comet or a meteorite would in an ideal universe, or in this simulation, I'd say. So I'm not an astrophysics or astronomy major, so I am not entirely sure how accurate this simulation is. But here's what I do know. That the basic reason that planets revolve around or orbit the sun is that the gravity of the sun keeps them in their orbits, just like the moon orbits the Earth because of the pull of Earth's gravity. And the Earth orbits the sun because of the pull of the sun's gravity. And this simulation just simply hopes to achieve on a very basic and primal level what would happen when a user would interact with a solar system by sending asteroids into a solar system with strong gravitational forces. What would happen? And okay, that is all for today.